Okay, in the next lesson here, or in the next part of our lesson, what we're going to do is we're going to be working on coterminal angles. There's a couple descriptions of coterminal angles that they have in the book. I'm also going to show you just some color pictures, but the main idea between coterminal angles are two angles that have the same initial side and terminal side. So in the diagram they have here, if we start with the initial side on the x-axis as in standard position, and we rotate counterclockwise in a positive direction, and this is our terminal side, then one way to measure this angle is what they're using, the symbol alpha. We're measuring a positive direction, so we're going counterclockwise, and we stop on our terminal side here. That would be the positive angle that we could measure it in. We could also start from the initial side and rotate clockwise, and if we rotate clockwise, we could go to the same terminal side on our angle, but we're going to name that beta. So we can always name an angle either in positive measurements or in negative angle measurements. And I just grabbed another picture over here to help you see that if our initial side is on the x-axis and we rotate a positive 120 degrees, we're going to end up at the exact same location if we start on the initial side and we rotate a negative 240 degrees. So what we're saying is there's really two different ways that we can name coterminal angles using both positive and negative angle measurements. There's another way to get coterminal angles, and that is by using only positive or only negative. Typically, we'll use only positive angles, and that means we're going to wrap around our axis, again, one full rotation. So in their picture, they have, if our initial side is on the x-axis in standard position, and we rotate an angle of alpha to our terminal side, then that is one way of naming that angle. Now another way is to take this same initial side and we wrap around completely in one rotation, 360 degrees, and then add on another same measurement of alpha. So these are called wraparound angles, where we just add on another 360 degrees to completely go around the circle again and get to the same terminal side. And here's another just graph of that. Here's one with a positive 30 and then a negative 330. That's if you want to name it with both positive and negative. But if you want to name it in another way, going only in positive direction, this 30-degree angle would be the same as a 360-degree angle plus another 30, which would be 390. So we have other ways of naming angles in more than one way. I got another little diagram here, a picture that I want us to keep remembering, that our unit converter for radians to degrees would be pi is the same as 180 degrees. I thought that was a good graphical way of seeing the connection between them. But so let's look at example 3 and what they're asked us to do. It says identify all angles that are coterminal to the given angle. Find and draw one positive and one negative angle coterminal with the given angle. So first of all, identify all the angles that are coterminal with the given angle, and then we're going to draw. So if it starts in degrees, we're going to finish in degrees. So if we have a negative 30-degree angle, I kind of like to take a picture of that in my mind. So we're going to rotate a negative 30 degrees. Our initial side in standard position is on the positive x-axis. Since it was negative, we're going to rotate clockwise. So there's our initial or our terminal side. This is a negative 30-degree rotation. Let's name all the angles that have the same name as this negative 30-degree angle. So one way that we could do this is by simply rotating around another negative 360 degrees in the in the clockwise position. So we could take a negative 30 degrees, and then we could subtract another 360 degrees, go clockwise around it, and then multiply that times n. Just says the n says we can multiply times any number of forward rotations. So I could go around it again and say, all right, then go around another 360 degrees in the clockwise direction. Now, more than likely, the textbook is going to give you just those positive ones. So what if we want a negative 30 degrees, and instead of going negative 360 degrees, instead of keeping in this clockwise direction, we could go counterclockwise and go 360 degrees around in the counterclockwise direction. So that would be plus 360 degrees times n. And the times n, the n stands for the integer, the number of times you want to rotate around either positive or negative. And since the n can be a positive or negative integer, what they will probably not do is they will not show you this negative one. They'll just give you the positive one. That's the simplest way to write it. Since n can be positive or negative, you can get both clockwise and counterclockwise directions. So that would be all the angles that are coterminal with that given angle. Then we want to draw and find one positive and one negative coterminal angle. So I'm going to clear up this picture again. So if we rotate our 30 degrees from our initial side to our terminal side, that's 30 degrees. in a negative sense. One way that I can get a negative coterminal angle is to take and subtract 360, so a negative 30 minus 360, that equals a negative 390. That's one negative angle. Then I could also do one with a positive. So I'm going to go negative 30, and this time I'm going to go in the positive direction, 360 degrees. So plus 360 degrees equals 330 degrees in the positive direction. So dealing with coterminal angles, both positive and negative, and getting a visual identification of what they're asking you for. Okay, so the next one is in radians. So it's going to be a little bit of a challenge here to think about where 3 pi force is. If you work anything like my mind, I always like to think about in radians, what is this in degrees? So I know that pi force is always a 45-degree angle, and I'm going to have 3 of those 45. So this is what in my mind works. I have 3 of the 45-degree angles, and if I have 3 of the 45-degree angles, that's 90 and a 145. That should be a 135-degree angle. So in essence, what I'm saying is I kind of convert my mind first and then come right back to the radians. So this is a positive 3 pi force, so that's going to be a 45-degree angle, reference angle, in the second quadrant. That's a 3 pi force rotation. So there's our initial side, our terminal side, and our angle. Now, how can we get all the angles that are coterminal with that angle? Well, I want to start off with 3 pi force. That's our angle, and then I want to include all the wraparound angles that we want to include. So one way is I can start rotating 360 degrees from where we started. So if I wrap around another 360 degrees, or since we're in radians, 360 degrees is the same thing as 2 pi. If pi is equal to 180, then 2 pi have to equal 360. So wraparounds in radians is always adding on 2 pi radians. And now we want to take care of the infinite set of wraparounds, so I could wrap around again, which means we're going to multiply it times n, where n can be an integer. Since it can be positive or negative, that integer, that takes care of both our positive rotations going counterclockwise, which I've demonstrated here, and it also takes care of the negative rotations that you could do. If you have n being a negative 1, that would be a negative 1 rotation, or if you want to go a negative 2, then you'd have a negative 2 pi rotation. So we just took care of all of those. So that's the statement that they would like you to get to anytime they want you to identify all angles that are coterminal. Second thing, we're going to draw a couple of pictures here. One that is coterminal going in the positive direction, so this is 3 pi force. We want to make sure that we go around one more rotation. One more rotation is going to add on another 2 pi. So what is 3 pi force plus 2 pi? So that's the math that we're going to have to do with this. 3 pi force plus 2 pi, that's 2 pi over 1. So 2 pi in the common denominator, we're going to have to make this a 4. Multiply times 4 makes that an 8. So now we're going to have 11 pi force. Now that's the positive one. If we want to get the negative angle that is coterminal to it, we'll take 3 pi force. And this time we'll rotate the other direction. We'll rotate in a counter or a clockwise direction, so we want to subtract 2 pi, which again we're going to change it to force. So 8 pi, so then we're going to have a negative 5 pi force. So when they ask you to do that, that's what we're up against. We're trying to find those rotations both in the positive and the negative direction that are coterminal to the original angle that they give you. Don't get frustrated with the radians. It's going to take a little while to get used to those conversions and bringing them back and forth between degrees and radians, but it just will come with practice.